Are you struggling to get RGB pixel buffers from Apple's ARKit? You're not alone. Today, we're diving into how to convert YCB CR pixel buffers to RGB format in your AR applications. I totally get it. Working with ARKit can be tricky, especially when you're dealing with color spaces. Many developers face this challenge, and it can be frustrating when the documentation doesn't provide a clear solution. Here's the specific question we're addressing today. One user asked, how can I get a CV pixel buffer in RGB color space from ARKit? They mentioned that the pixel buffer they receive is in YCBCR format and they need help converting it to RGB. Sound familiar? Let's tackle this together. So why is this happening? ARKit provides pixel buffers in YCBCR format for efficiency, but RGB is often needed for image processing tasks. Understanding this conversion is crucial for your AR projects. And stick around. At the end of this video, I'll share a quick tip that will make your color conversions even easier. To begin converting the pixel buffer from YCBCR to RGB, the user should first access the pixel buffer from the AR frame. This can be done within the session update method. Next, the user needs to create a new CVPixelBuffer to hold the RGB data. This involves using the CVPixelBuffer create function to allocate memory for the new buffer. Now, the user should perform the color conversion. This can be achieved using the vImage framework, which provides efficient functions for image processing. Finally, the user should ensure that the RGB pixel buffer is ready for use. This may involve locking the base address and performing any necessary cleanup. Fun fact: the YCBCR color space is often used in video compression because it reduces the amount of data needed to represent an image. Who knew color spaces could be so fascinating? Now, let's look at the answers provided by other users. An alternative approach shared by another user involves converting a YUV image to a UI image, which can then be saved as a JPG or PNG file. They provided a Swift code snippet that utilizes core image to achieve this conversion. Let's take a moment to review another user's answer. An alternative approach shared by another user highlights that ARKit captures pixel buffers in a YCBCR format. To convert this to RGB, you need to access the luma and chroma planes of the pixel buffer. This means you cannot directly obtain RGB planes, and you'll need to handle the conversion in your shaders using Metal or OpenGL. Now let's see a response from a different user. An alternative solution suggests using the Accelerate framework's image conversion functions. Specifically, you can use vImage convert 420YP8CB8 CR8ARG8888 to convert the YCBCR pixel buffer to ARGB format. If you don't need the alpha channel, you can follow that with vImage convert ARGB8888 to RGB888 to get the RGB format. This method is reported to work in real time. That wraps up that answer. Let's move on to another one. An alternative solution provided by another user involves processing the image buffer directly. They check the pixel format type and lock the base address of the image buffer. Then they retrieve the width, height, and bytes per row of the pixel buffer. The user defines a function to convert the YCBCR format to RGB, iterating through the pixel data to calculate the RGB values. Finally, they store the results in an RGB buffer and unlock the base address. Here's that quick tip I promised. Always test your color conversions with different lighting conditions in your AR environment. This will help ensure your colors look great in all scenarios. And there you have it. You should now be able to convert YCBCR pixel buffers to RGB in your ARKit projects. If you found this video helpful, please subscribe for more tips and tricks on AR development.